Hello learners, welcome to the course Statistical Methods for Economics Module 3. In this session, we will discuss the concepts related to the display of the univariate data with appropriate tools, the display of the bivariate data with the appropriate tools, the construction of histogram and its interpretation, the construction of frequency polygon and its interpretation, the construction of ogive and scatterplot. In Module 2, we had discussed about classifying and tabulating the data, construction of univariate and bivariate frequency distribution, also the concepts of marginal and conditional frequency distributions were discussed. In this module, we shall discuss the visually presentation of the data and the interpretation of it. Although tabulation is a very good technique to present the data, but graphs are the advanced techniques to represent the data. As a layman, one cannot understand the tabulated data easily, but with only a single glance at the graph, one gets complete picture of the data presented. M.J. Morone says that diagrams register a meaningful impression almost before we think. In this module, the few graphical representations we shall discuss are histogram, frequency polygon, ogive, scatterplot. Now, we shall look each one of them in detail. Histogram. Histogram is one of the most popular and commonly used devices for charting continuous frequency distribution. The construction procedure consists of erecting a series of adjacent vertical rectangles on the sections of the x-axis with bases equal to the width of the corresponding class intervals, and heights are so taken that the areas of the rectangles are equal to the frequencies of the corresponding classes. While constructing the histogram, the variable values are taken along the x-axis and the frequencies are taken along the y-axis. Now, we shall understand how to construct the histogram with the help of an example. The following data is the data related to annual imports of a selected group of economic suppliers. We are interested to portray this in the form of histogram. Here, the imports given in $1 million is the variables and is already given in the form of class intervals, and the number of suppliers is frequencies. The condition we have to first confirm is that the class interval are of exclusive type. Looking to the data, it is exclusive type. So, we can construct the histogram directly. In case if the class interval is of inclusive type, then we need to convert to exclusive type before the construction of the histogram. First, check whether the entire class interval is of same width. We observe that the width of the first class is 5 minus 2, which is equal to 3. Similarly, checking for all the classes, we observe that the width of all the classes is equal to 3. Hence, we construct the histogram of equal width. The important point in the construction of graph is selection of the scale. For the considered example, the variable is imports in $1 million, which we shall take in x-axis, and the number of suppliers is the frequencies we shall take in y-axis. The width of the class interval is 3. Hence, we shall define the scale in x-axis as 1 centimeter is equal to $3 million. The minimum number of suppliers in the given data is 1 and the maximum is 20. Hence, we shall select the scale in the y-axis as 1 centimeter is equal to 5 suppliers. The x-axis and the y-axis intersects at the point 0, which is called as the origin. Now, in x-axis, the markings as per the selected scale is as follows: 2, 5, 8, 11, 14, 17. And the markings in the y-axis as per the selected scale is as follows: 5, 10, 15, 20. In the x-axis, as the width from 0 to the first value is not the same as of the other values, we put a kinked line there. Now, in the considered data, observe that there are 6 suppliers whose annual import is between $2 to $5 million. So, in the y-axis, mark a line at the point 6 for the interval of 2 to 5 in the x-axis and join them with perpendicular lines to x-axis. Next, we have 13 suppliers whose annual import is between $5 to $8 million. So, in the y-axis, mark a line at the point 13 for the interval 5 to 8 in the x-axis and join them with perpendicular lines to x-axis. Similarly proceeding, the histogram of equal width can be constructed for the given data. The graph will be complete only when you give a suitable title, which is usually placed at the top of the histogram, and labeling the x-axis and y-axis. Now, let us consider another example of the frequency distribution of the monthly wages in 1000 rupees of the workers of a factory. As the data is in inclusive type, we convert it into exclusive class interval. The upper class limit of the first class is 19 and the lower class limit of the second class is 20. So, there is a difference of 1 point between them. So, to convert them exclusively, equally distribute the difference between the limits. That is, add 0.5 to the upper class limit and subtract 0.5 from the lower class limits. The exclusive data is as shown. Now, check whether the entire class interval is of same width. We observe that the width of the first class is 19.5 minus 9.5, which is equal to 10. For the second class, the width is 24.5 minus 19.5, which is equal to 5. For the third class, the width is 34.5 minus 24.5, which is equal to 10. For the fourth class, the width is 49.5 minus 34.5, which is equal to 15. And for the last class, the width is 54.5 minus 49.5, which is equal to 5. Here, observe that the width of all the classes is not same. Hence, we construct the histogram of unequal width. In the construction of histogram of unequal width, the variable, that is monthly wages, is considered in the x-axis and the frequency density is considered in the y-axis. We note that the frequency density is given by frequency of the class divided by width of the class. For the considered example, the frequency densities are as shown. Here, we shall select the scale of x-axis as 1 cm is equal to 10 width and in y-axis 1 cm is equal to 0.5 frequency density. Now, in the considered data, observe that the frequency density of the class 9.5 to 19.5 is 0.8. Hence, in the y-axis, mark a line at the point 0.8 for the interval of 9.5 to 19.5 in x-axis and then join them with perpendicular lines to x-axis. The frequency density of the class 19.5 to 24.5 is 3.6. Hence, in the y-axis, mark a line at the point 3.6 for the interval 19.5 to 24.5 in x-axis and join them with a perpendicular line to x-axis. The frequency density of the class 24.5 to 34.5 is 1.2. Hence, in the y-axis, mark a line at the point 1.2 for the interval 24.5 to 34.5 in x-axis and join them with perpendicular lines to x-axis. Proceeding similarly, we get the graphical presentation of the data. Frequency polygon. Frequency polygon is another device of graphic presentation of a frequency distribution which helps in understanding the shapes of the distributions. They almost serve the same purpose of histogram but are especially helpful for comparing the data sets. Frequency polygon is obtained on plotting the frequencies on the y-axis against the corresponding values of the variables on the x-axis and joining the points so obtained by straight lines. The frequency polygon can be constructed in two ways. One by constructing the histogram and the other without constructing the histogram. First, we shall see the construction of frequency polygon using histogram. For this, let us consider the example for which histogram was constructed earlier. In the constructed histogram, in each of the bars, identify the midpoints and mark them. Now, join these midpoints with the help of a straight line and complete them into a polygon by joining the lines to the lower limit of the first class and upper limit of the last class. The graph so obtained is frequency polygon using histogram. Now, we shall see how to construct frequency polygon without using histogram. For this, again, we shall consider the same example. For the considered frequency distribution, compute the midpoint as discussed in Module 2. Now, the midpoints are considered in the x-axis and the frequencies are considered in y-axis. For the class 2 to 5, the midpoint is 3.5 and the frequency is 6. Hence, mark at a point where 3.5 of x-axis and 6 of y-axis intersects. For the class 5 to 8, the midpoint is 6.5 and the frequency is 13. Hence, mark at the point where 6.5 of x-axis and 13 of y-axis intersects. Similarly proceeding, all the points are marked and then they are joined with the help of a straight line, which results in the frequency polygon without using histogram. Suppose we join these points with the help of a smooth freehand curve. The resulting graph is a frequency curve. Ogive. Ogive is a graphic presentation of the cumulative frequency distribution of a continuous variable. It consists in plotting the cumulative frequencies in y-axis against the class limits in the x-axis. As we know that there are two types of cumulative frequency distribution: less than and more than cumulative frequencies. Accordingly, we have two types of ogives, that is, less than ogive and more than ogive. We shall now look into the construction of the ogive with the help of an example. In order to construct the ogive for the given data, we shall choose the scale in x-axis as 1 cm is equal to 10 width and y-axis 1 cm is equal to 10 counts. Now, to draw the less than ogive, the less than cumulative frequencies are plotted against the upper class limits, So the upper limit of the first class is 14 and the less than cumulative frequency is 20. So we plot the point where the value 14 in x-axis and 20 in y-axis meet. The upper limit of the second class is 18 and the less than cumulative frequency is 25.7. So we plot the point where the value 18 in x-axis and 25.7 in y-axis meet. The upper limit of the third class is 25 and the less than cumulative frequency is 13.5. Hence, mark the point where these two values meet. Proceeding similarly for all the upper limits and their respective less than cumulative frequency values, and then joining them with the help of a smooth freehand curve less than ogive can be obtained. Now, to draw the more than ogive, the more than cumulative frequencies are plotted against the lower class limits. So, the lower limit of the first class is 0 and the more than cumulative frequency is 100. So we plot the point where the value 0 in x-axis and 100 in y-axis meet. The lower limit of second class is 14 and more than cumulative frequency is 80. So we plot the point where the value 14 in x-axis and 80 in y-axis meet. The lower limit of the third class is 18 and the more than cumulative frequency is 74.3. Hence, mark the point where these two values meet. Proceeding similarly for all the lower limits and their respective more than cumulative frequency values, and then joining them with the help of smooth freehand curve more than ogive can be obtained. So, note that the less than ogive is obtained by plotting the less than cumulative frequencies against the upper limit of the respective classes, and more than ogive is obtained by plotting the more than cumulative frequencies against the lower limit of the respective classes. Certain points to be noted while constructing the ogive, such as the frequency below the lower limit of the first class is 0, the ogive should start on the left with a cumulative frequency at the lower boundary of the first class. Less than and more than ogive can be drawn on the same graph. The less than ogive and more than ogive intersect at the point. The value x-axis from that point of intersection gives the median value. Ogives are particularly useful for graphic computation of partition values. Now, from the above constructed ogive, we can quickly note that only 25.7 of the people are of age less than 18 years and most of the people are of age less than 14 years. Scatter plot. A scatter plot is a starting point for a bivariate analysis. A scatter plot shows n pairs of observation as dots on the x-y axis. The scatter plot is created to investigate the relationship between the variables. Now, let us look into the construction of the scatter plot with the help of an example. The data is related to the overhead expenses and cost of production. To represent them in pairs, choose any variable in x-axis and other variable in y-axis. Let us consider overhead in x-axis. The minimum value is 80 and the maximum value is 160. Hence, we shall consider the scale as 1 centimeter is equal to 10,000 rupees and have a kinked line from 0 to 80. In the y-axis, we shall consider the cost. The minimum value observed is 15 and the maximum value is 19. So, let us select the scale as 1 centimeter is equal to 1000 rupees. and have a kinked line from 0 to 15. Now the first pair of points is 80 and 15. So put a dot where these 2 points meet. The second pair of points is 90 and 15. So put a dot where these 2 points meet. The third pair of points is 100 and 16. Hence put a dot where these 2 points meet. Proceeding similarly, the scatter plot is obtained. Summarization. In this session, we have discussed about the various graphical representation for univariate and bivariate data. Under univariate graphical representations, the construction of histogram with equal width and with unequal width, frequency polygon using histogram and without using histogram, cumulative frequency curve, both less than cumulative frequency curve and more than cumulative frequency curve has been discussed. Under the bivariate graphical representation, scatter plot has been discussed in detail. Thank you.